And let's move on to execution stack. So we kind of have two general ways that we organize applications. One of them is a whole bunch of individual scripts. We would say operations are encapsulated each within a number of different PHP files. So you go to one script to get one thing to happen, you go to another to get another thing to happen. Very common in the PHP 4 days, less common in large applications in PHP 5. But in this type of scenario, you just kind of load, you've got some common library that you just load in. In the model view controller is similar. You've got all requests routed through a single script, and so the router is delegating to controller objects and methods. Kind of just two general ways that we do application logic. And so then the question becomes, well, how do we add to execution? So we want to add a buffer, we want to add a cache, a log, a hook, we want to add something. How do we actually add to execution? With individual scripts, what that means is we need to modify that core library with new functionality. We might files and whatever, but ultimately we need to drop our functionality into that common library. With the model view controller is similar. Well, we can modify that single script that all requests route through, or again, something that's included by that, but that's the idea. But unfortunately, this means we're changing a core framework file again. This is the same problem we come back to with why we don't just simply change the vendor files when we want to make the object do something different. Instead of changing the vendor files, we go ahead and we built this nice extensibility structure. The same thing happens here. We would have to change the file to change the execution, at least in this setup. So before I get too much into the execution stack concept, let me just go ahead and talk about the observer pattern, just kind of in general in SPL, which is the standard PHP library. So we've got basically an observer that accepts some subject in an update method, and we've got some subject that basically an observer can attach to and get notified when something happens. And all it really does is the notify function sends the observer itself. And so this is kind of an implementation of that. It's not real code, but it's basically the implementation. And so then with execution, we can take this a little bit further. So this is one of many different ways to implement it. Again, don't worry too much about the particular implementation I focused on here. Just a simple thing. We put an attach and a detach. We allow, we just throw the observers in this array. And when we execute an event, so when the system says, I'm going to render, or I'm going to initialize, it just goes ahead and loops through all of them and sends the event. Not the most performance efficient way, but still really just a trivial way to send messages, and then each of your system observers just accept this execute event. So what you might end up with is something like this. You might say, well, I've got the system, it fires up, I attach this template object, a bunch of other objects later on, then we go ahead and we say we're going to execute preprocess, we're going to execute render, we're going to pre-render, we're going to render. Right? We might choose some stuff like that. And then the template, which is now attached itself, might simply just handle those events, and it might just say, well, on pre-process, let's just start the output buffer, and on content, let's just get it and render it out. There's not really this is kind of just a sample example to show the way in which this can work, but it's basically it. Let's just say that render function actually wraps it up in the template, and then you output it out. So this is really all there is to doing your entire application as just observable events, and now you're not actually writing all your logic directly into that file, you're just attaching, so you can always attach something new. So let's say we've got a configuration file that just sets those system observers. So I can just go ahead and I can add a whole bunch of observer objects into some folder, and then I can just set them in the configuration file so they're automatically attaching. Now those observers, they attach before the events fire, obviously, otherwise they're not going to get the notifications. The events are passed to those observers, and if they care about the event that's being passed to them, they go ahead and act accordingly. And this is really, really good for buffers, caches, logs, hooks. I would say that you can actually do much more complex things with that too. You can actually do things like MVC and the routing itself and all of that. You can actually bury all of that inside of just doing event listeners for your entire application's execution. And so in the wild, Laravel's got a robust events infrastructure, a lot of things that you can listen to and attach to, but it's not necessarily using this paradigm for the entirety of its execution. Not everything just attaches to an event stack, but you at least can listen in and add your own pieces to your event stack, and just a few of the options, and there's many more, so you can find those all on the Laravel documentation site. And then truly event-based execution in the wild, just threw up a little example. Basically, I've got everything from my response, which is going to be buffering all my output, to my router, all getting thrown in there. And then at just different points, you know, application initialize, you know, HTTP response is going to start buffering the HTTP body, so we're not going to start shooting information out before we've, say, written our headers. And then when we get to render, we're actually going to send that body. And so all I'm doing here is I'm just listening. Now in this particular case, the application actually kind of uses some special method names, but it's essentially the same idea. And you can kind of check that one out if you're just curious at that link. And so just kind of to return to why, the idea is to let the developer attach where they want to attach and when they want to attach without modifying your core or relying on any sort of kind of global knowledge of the system. So any questions on that before I jump over to MVC routing? No? Yeah?
How do you handle documentation? Can you go back one? All right, so that's the application rendered and initialized. How many more are there, and what are they, and how are they supported? And
oh, I'm just giving a toy example here. I'm not digging into how you would actually document all this stuff out. But I mean, honestly, when it comes to like the application stuff, you know, what you've essentially done here in this particular case is you've defined some sort of a convention, right? You've defined a convention that says, well, application happens to basically do dispatch oriented, like basically just invoke functions. If this class responds to an event, it responds with a particular method. If it has this method, it will call that method when it gets to that phase of execution. In this case, it's saying, well, on initialize and render, it'll do something.
So you're saying that this part of the code isn't actually implementing that pseudocode below. You just have the.
Oh no, it is actually. Execute in this particular case, if you actually go to this toy here, what it's basically doing is it's just saying, okay, well, in the initialize function, we'll call __ application initialize if it exists for each of the listeners. But it's a syntactic choice. You can just as easily throw in a switch statement and just accept this, you know, accept different strings and put different logic.
You need to come to the agreement what kind of events.
Yeah, here. Another way you could do it. I mean, so let's take a look at this one, right? In this case, I've just got two cases instead, right? So it's a switch statement in this example. So it's another way of handling events. You can actually accept different types of objects. You can accept an object that actually tells it what it is. Lerigot, which doesn't actually use events to drive everything, but it does provide you events. They just have a whole bunch of events, and they've kind of loosely documented them. Some are better documented than others, actually, among their set of events. But again, it's just things you attach to it. So every framework defines a way in which you want to attach. I wasn't going to get too deep into how you make decisions about which style is right, but if you'd like.
No, I'm just really interested in event models, and so it also looks like those are side effect free. Is that how you?
Yes.
Okay.
Well, I guess side effect free in which way?
Okay. So sometimes what event models will do is they'll give you some object that you can sort of tweak and modify as you pass things along.
Oh, right. No, in this case, yes, that's correct. I'm just for the event model for the application itself. I wasn't passing anything in particular. Okay. Yeah. Okay. Any other questions? Okay. So then just talk a little bit about MVC routing, which is another kind of big question that people often have open. So kind of one of the kind of common paradigms is just use implicit routing. This is something we saw in most of the frameworks of, say, maybe 5 years ago, most of the MVC frameworks. You had a scheme like, you know, question mark, controller method, and some arguments, and basically what that would do is you'd say the first one define the controller, the second define the method, the third define the arguments. You might transmute these in some way. You might have a different syntax for how you load them. But it was essentially this type of an approach. And so, for example, you might end up with, you know, news category tech news calls the controller news with the category method and the parameters test and news. Kind of common way of doing implicit routing. And so implementing it's pretty easy. This again is just kind of a toy, but basically you just take the segments, chop them up. Let's accept they're an array here. You return the first segment as the controller, second segment is the method, and the rest of the segments are the arguments. And it really is about that simple. And to implement it with the actual execution, it literally is just assemble that class name. In this case, I threw it in a namespace, but you know, a lot of the older frameworks before you had namespaces kind of universally implemented, they just do controller underscore and then the actual, like just the string underscore controller after the controller name. You just instantiate that class, you set up callback, you make the callback, send it the arguments, the method. It's Pretty much kind of simple controller method delegation. But then we started getting a little more complex because we had controllers where it was like, well, I want to have this kind of hierarchical MVC where I've got some modules and stuff. And so one of the easiest ways to do it was basically just add a different separator. Add a separator that says everything up to this point, we're talking about the modules. We define a module and then load the controller inside that module with the methods and the arguments that we want. Unfortunately, there's still rigidity. We don't have the ability to just kind of go in there and tweak on the way we want routes to be handled. We are stuck with one approach. If this is the way I've defined it and I say how I'm going to resolve to a particular module, and I say how I'm going to basically extract this controller argument and this method argument, and the rest of the arguments that are going to be passed as function parameters, I'm stuck with that. Another problem we have is the different HTTP methods. REST is really common nowadays. We want to be able to take advantage of the different HTTP methods. Convention. The implicit router can figure out what method was called, but it still needs a way to name the methods differently. And so you might end up with something like, I don't know, throw the method name in front of the function, in front of the actual method name that's specified in the controller string. But again, we have rigidity, and this is a problem. And so that introduced the idea of explicit routing. So instead of using a convention to drive everything, instead of telling everybody this is the way you have to work, instead we said let's not force a convention, not even MVC. So now I'm going to be using some Laravel examples for a little bit because they've kind of in many ways their routing is very similar to what you'll see in a framework like Rails actually. And so I'm just going to use some examples of that here. So you can basically pass it. This is basically the same thing. This is news category and then 2 extra values, and it actually invokes pretty much the same thing, except in here we're just invoking a function. Now we have clear support for different HTTP methods, because when we're defining these routes, we can just say, oh yeah, use get or post or put or delete. So we actually get that. We get that clear support. We can now be explicit in how we want to handle this. So we're no longer talking about just naming all of our controller methods by convention, but now we're saying we can actually pick and choose how we want to name everything, and then how we want to name our routes as well, and how we want to bind the 2 sides. And then we can explicitly route to controllers. And so, for example, this, again, actually the syntax is stolen directly from Rails, but here you can just say, well, news category routes to the news controller category method. And it's that simple. And so we've got a lot of flexibility now, but unfortunately we're also very verbose. Imagine if you're expressing all your routes like that. Every single route in your system you're going to have to actually write out explicitly. That's a lot of routes you got to write out, and you may forget one, you may change one later on. So there's a lot of clarity that comes from explicit routing, but there's also a lot of words. So then we can do explicit routing with implicit routes. So I would say that explicit routing with patterns is very much just a superset of implicit. You can do anything with explicit routing with patterns that you can do with implicit, and this is kind of how. I mean, literally, this is just overriding the entire router engine. So now you just go ahead and define your explicit routing convention the way you want to, or your implicit routing convention the way you want to. So if you're implementing a baseline framework, you may want to actually just think about, you may just want to include everything as explicit routing. And as long as you include patterns, somebody can always cheat and add their own implicit routing as well if they'd like. So that, for example, is what Laravel did. Now it simplifies, you can also simplify the implementation with controller support. So you might add a method that's like controller news, and then you detect all the methods in news, you come up with a convention that works for it. But again, now I'm saying the word convention, so we're talking about implicit again. And in the case of something like Laravel, we actually go all the way to the point of actually being able to detect all the controllers in the system and load all of them in the same way. But now we're back at simplicity with the cost of flexibility. So we've gotten away from the verbosity, but now we're starting to head back towards the implicit routing scheme. And so the question really becomes which is best, and my argument there is it really completely depends on your use case. What is it that your organization needs? What is it that your framework is trying to do? Are you trying to enable somebody to work in any pattern they could possibly want, or do you want some level of convention? Convention can be good. It can force people to have to work in a way that if you transfer somebody else onto the project, they adapt. But then your framework isn't as generic. Your framework forces things on people, at least at some level. So just something else to keep in mind. Any questions on routing before I jump over?
Well, the routing, like, wouldn't you want to have some sort of a consistency with your routes, like in the way how you name objects and,
Yes.
Because if you go for like, okay, for one controller, okay, the object name is first and the ID is second and stuff like that, and like for like other controllers it really
To a point that, yeah, to a point you want consistency, but what happens if you're implementing a bunch of vendor modules that have controllers in them? And they may have structured the way that their methods work very differently from the way you've structured yours. They may not follow your convention at all. And so if you go with explicit routes, as long as you include patterns, you've still got your implicit routing engine if you want. If you add some sort of a precedence order to the way you do your routing, you've actually made it even easier, because now you can always fall back to your implicit router if all the explicit routes don't match. But now you've made it really easy for you to implement exactly what your vendors have done for their controllers. So.
And there is also like the execution cost if you have like a lot of explicit routes, like seem like hundreds.
Not necessarily. I mean, a lot of that stuff can cache and stuff, and I mean, I don't see that as. Remember, we're talking about websites here, right? The predominant amount of response time on a website is not route resolution. So, I mean, database interactions. If you've got a different database server somewhere else, one database interaction probably out trumps an entirety of 100 route resolution attempts. So, any other questions on that? Yeah.
So one combination that you didn't mention, which I don't know if this makes any sense, but you mentioned implicit, you mentioned explicit, and then you said explicit with implicit, right?
Right.
But then implicit with explicit, is that it's to me? I mean, I'm still learning, all this stuff, and the way I understand CodeIgniter handles things is it starts with a convention, but then you can overwrite that with other routing patterns. So
yeah, I would still say that's actually explicit with implicit support, because what they've done is they've set this baseline that if everything else fails, we'll fall back to this implicit route, and then they let you go explicit on top of that. So, other questions about routes? Or? Okay, let's talk about buffered output. So, for those that aren't too familiar, there are a set of functions that are ob underscore this and that, and these are the output buffer functions. So, for example, in this very, very trivial thing here, we've got this, we start a buffer, then we echo z, but then we ob clean, and we say, no, skip that. So at that point, z will never print, z just poofed. Z was in the buffer, we dumped the buffer without printing it. Now we go along, we echo a, still nothing is printed to the screen, but then we call flush. At that point, it's going to print a. So at this point in execution, A has been packaged up and it's been sent as part of the HTTP response, part of the body. And then the server keeps on churning and echoes B and C. It doesn't send B and C right away. They're both sitting in the buffer now. And then we do an end flush. And this time we end the buffer. We're not buffering anymore. And we go ahead and we flush the rest out. So we send B and C as well. So we end up actually printing. What we end up sending at the end is we end up sending A, B, C. We don't send Z. So that's the basic idea of an output buffer. And one of the coolest things that output buffers can be used for, just kind of a trivial cool thing, is that you can actually capture non-return value function output. The most common function that this is var dump. People want to write echo var dump, but it's not echo var dump, it's just var dump. It prints the output out anyways. But what if you actually want to catch it? You can actually use an output buffer to do so. If you go ahead and you say ob start, and then you call var dump, now var dump's output has been put into the output buffer. You can get that output buffer, and then you can clean the output buffer. You can say, no, let's end it, let's clean it. We don't want to put that output out. But before we did that, we went ahead and we assigned it to a variable. In this way, the var dump variable that I've got here has now actually captured the var dump string output. So it's kind of just a cool random thing you can do with output buffers, but it demonstrates, kind of loose flexibility. And more than var dump, you can also do this on include and require functions. And this is how views in MVC are implemented, generally. So basically, the idea of a view, for those that maybe aren't too familiar, is basically you've got an object that's representing a file. And you've got some variable support and stuff like that. So you can push variables into this object that will then become available in the view. This is kind of an example. So I just said new view. I've gone ahead and I've pushed bar into this foo attribute. Let's say in this particular example here, that what foo actually does when you push something into a property of this object, this view object, it actually just goes ahead and sends it into the rendition of the view. So in this case, we now have a foo variable that equals bar inside of our view. And then we just call render, and in this case, we're just assigning it to an output variable. This is the implementation of that. Basically, when I go ahead and I call that view foo, I just go ahead and I set, using the magic method, just go ahead and I set some, I go ahead and I set that as data. And then and then render, this is where I'm using the output buffer. I go ahead and I start the output buffer. Then, being in this function scope, I extract this data. So everything I've pushed in as properties on the object, those all get dumped into that scope. And then we go ahead and we include the file name. So we've got all these variables, now we've included the file, so we've loaded the content in, but we're in an output buffer, so we haven't printed any of the content. Then we go ahead and we use the same trick we use with var dump, and we go ahead and get that content. And once we get that content, then we close we end the buffer, and we clean the buffer without printing it out, and we return that content. And so we've now managed to load the variables into the scope, include the file with those variables, but not output it, just capture the output, and then return the output. So that's basically a trivial implementation of how views are often done in MVC. So beyond views, we can also use this to buffer HTTP response bodies. So I guess the easiest question would be why, and the easiest answer is so you can write headers at any time. Buffer everything, and say during the shutdown of the PHP script is when you actually go ahead and print stuff out. At that point, you've sent no HTTP bodies, so you can keep on sending headers. I'm sure that there are people here who at some point have done some PHP coding, and you've got some stuff happening, you're printing some stuff out, and then you're like, oh boy, I want to redirect. So I try to do a header location URL. But I can't send header output, body already started, or some error message like that. So this gets around that problem. You go ahead, you throw everything in a buffer, and you print at the end. Now you can call header at any time because you've yet to send any body content. It also lets you clear the buffer. And if we're in MVC, you can actually reroute internally. You don't need to send a header, cause a new set of HTTP requests to fire. You can actually simply re-invoke the router, kill your current execution, and move off to that other router instead. And by clearing the buffer, you can have already, by clearing the buffer, you've already gotten rid of any output that might have been laid out to the screen otherwise. And you can do full page response caching. May or may not be useful. You may not want to do it at the PHP layer. You may want to do this at some sort of a higher level proxy, but you have the option to do that if you'd like to. Now, why would you not want to use a buffer? First one is the client must wait until the server is done before it starts downloading the body, the HTTP response body. If you're buffering all your content, you haven't started sending any of it yet. You're allowed to send some content and then send some more content and then send some more content. But if you're buffering it all, you've sent no content until you've finished execution. So kind of a negative. And it's confusing. And it's not, I say here it's confusing if it's not transparent, right? So if you don't ever interact with it and I'm just buffering in the background and I just tell you, oh yeah, anything you've echoed now, if you just call output clear, it disappears, and that's great. That's kind of transparent. And it's useful in a lot of ways. It's not too confusing at that point. You don't understand the underlying implementation. But it is still confusing if you want to change that, and it's very confusing if you actually have to explicitly call closing your buffer at the end. So your framework should certainly hide that internals of logic, but just recognize the fact that in some cases you are still making things more complex with a buffer. So in the wild, a couple examples here. Just going to pull out Laravel's application run and response.send. Just kind of one where they've got the output buffer being used. Something I would say is don't fight the language system down. Just like this type of a setup here with the send being where you're doing stuff, I'm not sure you need to, because what you're doing with send is you're saying, okay, by convention, send's going to be right at the end of my application execution. But if you don't fight the language system, why don't you just use the language system to do it explicitly? Hook into the shutdown routine. In this case, I've gone ahead and I've said, well, at shutdown, we're going to OB clean. Now, this makes no sense. I mean, because it's going to end, the OB is going to end anyways when the script shuts down. But if you're actually going to do something with this solves your problem. And actually, in this particular case, I think generally OB end flushes. So generally, anything in the output buffer, when it shuts down, if it hasn't cleared the buffers, it actually flushes all that content. So what this actually does is, say for example, I had done some stuff, and then I had sent my response, thought I had cleared out my buffer, I had done all my OB flushes, and then some more stuff printed. This actually makes sure that more stuff that printed doesn't get sent. So there is a use of some sort to this. But now this is still going to behave like any other output buffer, so you can still call OB flush, and you can still call OB clean. But instead of it being some explicit, you need to end this, you need to flush it, or you need to clean it at the end of execution, in your own application code, you've now just abstracted it into the actual PHP shutdown itself. Now, I mentioned that you can use output buffers for rerouting. What I mean by that is essentially as follows. And sometimes in MVC we have something like this. We have a post article, and basically we accept some post data. And let's say the post data validates. At that point, we want to go ahead, we want to create an article, right? And we'll get a news ID back, and then we want to send the user on to a different page. We want to show the user what they just created. In a lot of cases, you might do a header location and then go ahead and say, this MVC path of news article, news ID. But you don't actually have to do that. Another way to do that is actually just implement a reroute that internally reroutes things, so you don't send the extra HTTP requests. Now, basically, to implement that reroute, we just go ahead, we clean the buffer, we go ahead, we invoke our router again, we say execute this new path we passed, and then we just go ahead and exit. So we just kill execution at the point of the reroute. So what this does is that once this controller gets to router reroute, it goes ahead and spins up a whole new execution with a new segment, and it goes and does whatever that new execution wants to do, and then it exits right here at the end of this conditional, rather than going into any additional code. So we've now accomplished rerouting without writing any headers. So another kind of cool thing that comes out of output buffers. Now, I want to talk a little bit about objectifying the output buffer, because so far we've, earlier in this discussion I talked about autoloading. I talked about how cool it was in some ways because we could actually use that for seamless extensibility. So in the same way, why don't we go ahead and we objectify the output buffer so that we can simply drop our own class in later on that overrides some higher level class defined in the framework or by a vendor, and then we get to add in our own functionality. Whereas if we've just got these OBs, we've got to figure out how to hook in at the right point around those OB calls. So pretty basic, just a toy here. But the implementation, roughly equivalent, just now use the object to do it. It's doing essentially the same things, but now I can do some overrides. So, kind of already got there, but let's go ahead and add templating. Templating is something that we always want. We'll assume that we've got that autoloading that we talked about earlier with the namespace stuff. So let's go ahead and we'll say we have two namespaces. We have a framework namespace and an application namespace. Now we'll just go ahead and we'll define our application output, which is just going to extend that framework output, which, just to recap, was very simple, very boring. It was just wrapping the OB functions. But that's our framework output. And now with our application output, we don't touch the initialization, we just touch the shutdown. And in the shutdown, in this particular example, we're just going to go ahead, we're going to get the output buffer contents, rather than flushing them out like we generally would have. Instead, we're going to go ahead, we're going to clean the buffer out, we're going to end it. We're going to then load into the template. We're going to load in those values that were in the output buffer. We're going to load them into the template as a variable. And then we're going to go ahead and we're going to pass the template out. So just a very, very simple example. But we've basically added behavior now without modifying any framework code. So this is kind of one of those nice things about using autoloaders to actually do extensibility. In the wild, a couple of links you can refer to. Nothing big, just some toys and stuff to play with. These classes, the ones in the event repo, are very, very basic. They're all on their own, so you can actually just take them and drop them into your area as you please.